You're standing here. There's idyllic, pristine water behind you. But instead, you're looking at this through your sweaty eyepiece of your telescope in sweltering heat. You can see birds, crested terns, lesser frigate birds, brown boobies, some other species that's hidden behind another animal. And these seabirds are amazing indicators for the health of the vast marine ecosystems that support them. And your job? To count them. But you want to get it right, because you know this monitoring data is going to inform management decisions. This was me 7 years ago, and I thought, we need a new angle. We were amazed. In this inset here, you can even see in the top left-hand corner the contrast in the pair of lesser and greater crested terns. Individual birds were unmistakable. Surely this vantage would give us a precise estimate. But would it be accurate? We couldn't test this in the field because the number of birds were moving, and we also didn't know how many were there. But the Epic Duck Challenge could. You might have heard about a few thousand birds colonising Port Wollonga Beach about a year ago. We made life-size replica crested tern colonies, and we had professional ground counters count them from a distance. At the same time, we piloted a remotely piloted aircraft, or drone, above that colony. 10 colonies, in fact, ranging in size from 500 to 1,000 individuals. We then asked citizen scientists to tally the number of birds in that imagery. And so, thousands of these guys gave us an answer. Not only were drones more precise, but the estimates from the imagery were 43 to 96% more accurate. This was the first published study using life-size replicas to test the quality of bird count data. That pertains to traditional data as well as this new approach. Quite amazing, because by knowing the quality of the data, we can put bounds around the estimates we already have and the estimates we'll make in the future. So with this confidence, I was fortunate to be able to observe one of the Coorong Islands which consistently supports breeding Australian pelicans. Access was simplified by using a drone, and I captured imagery about every 10 days over the recent spring and summer period. On the left-hand side, you can see day 0, my first time point. And on the right-hand side, you'll see a transition of those next time points. Look out for the changes. What this is a 3D model. It's created from about 900 images that are overlap and taken in transects using a drone. As the pelicans incubate their egg for about 30 days, just over a month sometimes, we had multiple time points of the birds incubating, and then the following 3 months when the chicks grow to fledging stage. Over this period, you can also see that we've had a decrease in rainfall, an increase in temperature, and an increase in raging pelicans trashing all the vegetation on the island. So now, just to take you through a little zoomed-in section of this colony. This is a geo-referenced, ortho-corrected piece of the island, and you can see in the inset we have some pelicans sitting down. We can easily identify every individual, either manually or preferably semi-automatically, and we can use that over time to see what's going on. So if I flick you between these two, you can see in the lower centre the birds have moved down. So those birds weren't nesting, they were just sitting there. And the birds on the left-hand side are nesting because they're there. Take that 10 days forward, and you have chicks. Here's a zoom up of 2 little chicks from that inset. And 8 days later, those chicks have got larger. and some period down the track at day 88, they're quite large. They've crashed into little groups. You can see them around the bushes. And so we can look at that change in time and start to answer lots of different questions. We're still in the preliminary stages of looking at this data, but maybe we can start to understand the spatial dynamics of how the pelicans breed. Do they use the same places year after year? How will climate change impact them? Can we use this data to calibrate our historical aerial records? And so, Storm Boy knew Mr. Percival intricately, but he was just one pelican, sadly no longer with us. But this data allows us to know many pelicans intricately. And in case you're not convinced, you might say, Jarrod, these birds are massive. It's very easy to see them. Well, I've got a few other examples for you. Imagine if you came onto this island. There's crested terns there. And what about if you landed on an island, one of the best places I've been, a protected area where Australia's subantarctic endemic penguin breeds? You'd be confronted with this. Almost hunted to extinction in the 1800s, and I think you'd fancy this view if you had to count them. And moving forward, I've demonstrated that we have an accurate technique. It's low cost. Maybe we can use it for other animals. Take our other poster child, the endangered sea lion. Maybe we can use drone imagery to understand the condition of different populations. Thank you.